All right, so we're going to be continuing our work now with integration and the antiderivative. And just a review of last time, and there's no need to write this down, you already have it. The antiderivative, we're talking about the reverse of the derivative of a function. And when we have our notation here, when we're done finding the antiderivative, so far we've left it as the f of x and then plus that constant of integration c. And so because of that, because we're leaving it as c, that's called a general solution. And in this lesson, we're going to be talking about finding particular solutions. So what's a specific function given certain conditions? Okay. So here we go. We have initial conditions and particular solutions. That's the main topic for today. And then we're going to look at a vertical motion problem as well. So you can go ahead and write that down. All right. And let's take a look at our first example here. We're looking to find the particular solution where we're looking to basically integrate this. All right, we're going to have some function that is going to be the integration of 3x squared minus 1 dx. But then we're also told that f of 2 equals 4. Okay, so we're going to use that information to find a specific function now. All right, so let's see how this is going to work. First of all, let's integrate this function. Okay, so to integrate this, we're going to say, well, all right, that's going to be 3x squared. We're going to raise that 2 up to 3 and then divide by 3. So that's going to leave us with x cubed. And then minus the antiderivative of negative 1 would just be minus x. And then we would add on that constant of integration like that. Okay, so that's the integration portion of it. But now what we want to do is we want to take into account the fact that we know that f of 2 equals 4. So meaning when I plug in a 2 for x, I should get 4 as an answer. All right, so now what we'll do is the following. So we will replace the x's with 2's. So we're going to say, okay, that's going to be 2 to the third power minus 2 plus c, and that's all going to equal 4. Okay, so when we plug in 2, we're going to get 4, and what we're going to have to do is figure out what that c is. All right, so just algebraically speaking, we can figure this out. We can cube the 2, that is 8, minus 2, so that's going to be 6, plus c equals 4. And then whether it's mental math or using algebra, we would now know that c equals negative 2. Okay, so putting this all back together now, we have our general solution here, but we have figured out that c is negative 2. So now when we put it back together, we're going to say that f of x is going to equal x cubed minus x. And then instead of saying plus c at the end, we have minus 2. Right? So that is how we find a particular solution given an initial condition. Okay. Now this is going to come in handy when we do something called a vertical motion problem. And let's just see what we have here. All right, so we have a ball is thrown upward with an initial velocity of 64 feet per second from an initial height of 80 feet. We're going to assume the acceleration is a of t equals negative 32 feet per second. And what we want to do now is use this information and our integration techniques to find the position function. Okay, now just in case you're wondering, do we actually have enough information to figure this out without using calculus? And the answer is yes. Okay, but we do want to show how integration can work out for questions that are, possibly a little bit more challenging. Okay, so let's go back over here. Now, a quick review of some things is just remember we've dealt with the position function, velocity function, and acceleration. And it's up to you if you want to write this down or not. But just remember that, when we start off with the position function here, that's s of t. If we find the derivative of that, that's going to be velocity. So that's s prime of t. And then the second derivative of position, or the derivative of velocity, that's our acceleration. Okay, so we've dealt with that when we're dealing with derivatives. And now, since we're dealing with integration, we're going to have to kind of go backwards. Okay, so just keep that in mind as we work through this problem. Okay, so again, we look at some information that we have here. Okay, we have an initial velocity of 64 feet per second, being thrown upward. We have the initial height is 80, And then we're going to assume the acceleration if t is negative 32 feet per second. All right, so let's just see how we can work through this now. Okay, well, let's first of all start off with some given information. We're going to say now, we can start off with the position function. So s of 0, which is basically when time is 0, that's going to be 80. Okay, because that's the starting height there. And just a reminder here, that's going to be the position function there. We are also told about velocity, which is the first derivative of the position function. And so that's going to be, it's being thrown upwards, so that's going to be 64. Oops. And again, that is velocity. And then finally, we are assuming that the acceleration is going to be negative 32 feet per second. So it's acceleration, which we can also call the second derivative. Okay, that'd be negative 32, and that is acceleration. Okay. So what we essentially want to do now is, we're going to be taking this information. We want to eventually get up to this position function, but we've got to do so by starting off with acceleration and then going through that process. Kind of what we did before with going from a general solution to a particular solution. Okay, so so first of all, let's start now with, we'll switch this up. We're going to say here that, again, just a reminder that the velocity function, we are essentially going to be integrating the acceleration function. Okay, so again, going kind of backwards, we're going to go from acceleration to velocity, and then so we are doing the reverse of the derivative, which is finding the integral. Okay, so since we know that the acceleration is negative 32 feet per second, we are going to integrate that in terms of, notice we're going with t now, okay? So that's going to be a way to go from the acceleration to velocity. Okay, so just think about what that means then if we're going to integrate negative 32. Okay, and that is going to equal negative 32t, and then we'll add in the constant of integration. Okay, so that's going from acceleration to velocity. Okay, and now what we can do is we can figure out what this is, what this c is, because we know that, or from earlier, s prime of 0 is going to equal 64. Okay, we saw that. Oops, we saw that up here. Okay, so now, kind of using our technique from before, if I start replacing some things here, so I'm going to say that 64 is going to equal this right here. All right, so we're going to say negative 32 times 0 plus c. Okay, and again, that's because when t is 0, our initial velocity was 64. Well, then that tells us, mathematically speaking, that c is going to equal 64. Okay, so what that tells us now is, as far as the velocity function goes, if we plug that back in, s prime of t, that's going to be negative 32 t plus 64. All right, that is our velocity function. Well, what we're looking to do, though, is get the position function, which is s of t. Okay, so we'll switch over here. So, and just a reminder that s of t, to get that, we need to integrate the velocity function. Okay, so again, we're going backwards one more time. Okay, so what that means is we are going to integrate, well, s prime of t, that is negative 32t plus 64. And we are going to do that in terms of time. Okay, So we will now integrate this. So let's just think about this portion right here. Well, we would raise the t up to t squared and then divide by that 2. So that is going to equal negative 16t squared. Okay. And then looking at this part here, that's 64. That's just going to turn into 64t when we integrate it. And then we have to add on our constant of integration like that. Okay. And then just a reminder, we were told earlier that s of 0 equals 80. So going back over to here, we can figure out, all right, we'll put the 80 right here. So if we plug in 0 for t, that means 0 squared plus 64 times 0 plus c. That's all going to equal 80. Well, we now know that mathematically speaking, these two are going to turn into 0, which means that c is going to equal 80. Okay. So in the end, we can now say, by putting it all together, that the position function, s of t, is going to equal negative 16t squared plus 64t. And then that constant of integration we can add in is going to be 80. Okay? And again, you may be thinking, I feel like we could have found this out without the use of calculus. And the truth is, yeah, if we know the initial height, the initial velocity, and then we have our gravitational pull right here, we could have put it in there. But this is just showing how integration will work as well. And that's going to be useful for other types of problems where we don't know how to just plug in the values like that. So that's how we use integration when we need to get particular solutions. We'll do more of these in class, and if you have any questions at that point, you can let me know. All right, thanks.